Hey guys, and welcome to this private tutorial on the composition of functions. So hopefully by the end of this tutorial you'd have achieved these three learning objectives, being to understand and evaluate compositions of functions, to solve equations involving compositions of functions such that they equal 0 for instance, and to use compositions of functions to solve equations or questions, for instance these two exam questions over here, which we'll return to later on. So you may be asking yourself, what is a composite function? So basically, composite function is when you apply one function to the results or outputs of another function. So I have this little diagram to help explain it for me. So basically, let's say you start with an input x, it undergoes the function g, producing the output g of x, and this g of x becomes the input of f. So you would get f of g of x. So if the input was 5, and let's say the rule of g is you times it by 5, so if you get, and the rule of f was times it by 10, so let's say you get 5, okay, you times it by 5 is 25, right? So that's now the output, but now this becomes the input of f, you times it by 10, which is 50, so fg of 5 will be 50 with those two rules that I made. Now if you given two functions f and g, the composition function is just denoted by f of g. This is read as f composed with g or just f of g, and do not confuse it for fog. Alright, so that's not a little o. And any variable could be represented, representing a function, can be a, b, c, d, etc. It's just that f is commonly used because f, it can stand for function, so it's commonly used. For instance, you can have f of x is x plus 10, or g of x is x squared minus 5, h of x, or a of x. You can have any variable you want. So the notations. Now if you're given two functions f and g, the composite function could be denoted as f of g, which means f composed with g, or fg of x, or f of g of x, or fg x goes into whatever. Alright, so that's basically how they would look like. And let's quickly define these two functions, give you an example. If I said f of x was x plus 10 and g of x was 2x, so the composite function f of g of x, so what you would do basically is you take the input x, and g of x says basically whatever is in the bracket, whatever is the input, you times it by 2. F of x says whatever is the input, you add 10. So the composition f g of x, you start with x, you times it by 2, that'll be 2x, and you put this back into f, so it'll be f of 2x, and the rule says whatever is in the bracket. For instance, as you can see here, f of x and x plus 10, you add 10 to it. So as you can see here, g of x, this is x, the output is 2x. This is x, that's x plus 10. So basically, if you wanted fg of x, you'd get g of x, which is basically 2x, and you put it back into f, giving you 2x plus 10. And these are just the four ways you can denote the composite function. So fg of x is 2x plus 10, f of g of x is 2x plus 10, f of g of x is 2x plus 10, or fg is x goes into 2x plus 10. Usually the question will imply which form to use. If it doesn't, use the form fg of x because it's the simplest one. Composite functions are non-commutative. This means the order in which the functions are applied, it does matter. For instance, if you have g of f of x and you start with x, undergoes f, gives you f of x, goes to g, because this now becomes the input to it, gives you g of x. So the order does matter. So because if I for instance told you that f of x was x squared and g of x is 10x, right? If I define those two functions for you, and I told you to find the composition. So firstly, f g of x, you take x and you put it into g. G says whatever's inside the bracket, this is x, that's 10x, and multiply by 10. So it would become f of 10x. And f of x says whatever's inside the bracket, you square it. So it'll become 10x squared, which is 100x squared. On the other hand, g f of x, you take x, and as you can see, you square it, right? So that becomes x squared. So this becomes g of x squared. And G says whatever's inside the bracket, you multiply by 10. So this gives you 10x squared. So this is an example as to why f g of x does not equal g f of x. The order does matter. So evaluating composite functions. Here are several examples we will run through as to how you can potentially evaluate composite functions. So this first question says that f of x is 5x plus 3. This means that the rule input is 5, output is 5x plus 3. This means that whatever's inside the bracket, you multiply it by 5, then you add 3. And g of x, whatever's inside the bracket, you square it, then you multiply it by 3. So they told you to find f of g of 4. Now I'm going to rewrite it as f g of 4 just to make it simpler. So the first thing you do, right, is you have to find g of 4, because this will become the input into 4. So g of 4, what would that be? That will be 3 multiplied by 4 squared, because what's inside the bracket? 4. So you'll do 4 squared, then multiply that by 3, which will give you 48. Now you have to put this as the input into f. So it'll be f of 48. And the rule says you multiply what's inside the bracket by 5, then you add 3. So what's inside the bracket is 48. So you'll do 5 times by 48, add 3. This is 243. So f into g into 4, or actually f of g of 4, is 243. Here's a similar kind of question. Obviously we're going to be using a different notation, so kind of showing you that it depends on the question. So this one says if f of x is x plus 1 and g of x is x squared, find the following: f composed with g of minus 4. So again, you'd have to do g of minus 4 and then put that inside of f. Well, what's g of minus 4? So what's inside the bracket? Minus 4. What's inside the bracket? X becomes x squared, so you square it, so that becomes minus 4. All squared, which is 16. Okay, so now this becomes the input into f. So you get f of 16. Now the rule says whatever's inside the bracket, you add 1 to it. So this becomes 17. So basically f composed with g of minus 4 is equal to 17. Let's do the next question. This time it's g composed with f. So now what you do f of minus 5. F of minus 5. The rule says you add 1 to it. So this becomes minus 5 plus 1, which is negative 4. Now you do g of negative 4, which will give you 16. So this means that g composed with f of negative 5 is actually 16. So that is the steps required to evaluate a composite function. These are the skills, right? So if it starts with f into g of 4, you'll do this first, then put that into 4, and then vice versa if it's the opposite. Solving equations, the second learning objective. So this question says the function f of x is defined as x squared and g of x is 2x plus 3. And the first question is evaluating the composite function. So what we did on the other exercise, but now obviously it's going to be accompanied by other questions. So let's do A. So first we have to do g of 2. The rule said whatever's inside the bracket, you multiply by 2, then you add 3. So it becomes 2 times 2 plus 3, which is 7. Now you do f of 7, which is x into x squared. You square it, this becomes 49. So f g of 2 is 49. That's what you do for question A. The easiest one by far. Now we'll do problem 2 or B. It says find g of f of x. So first you have to do f of x. Now you're already given this in the question as x squared, but basically the way you would do this if you didn't know or if you didn't pay attention, what you do is the rule says whatever's inside the bracket you square it, right? So whatever's inside the bracket here is x, well it'll be x squared. So now you'll do g of x squared. And the rule said you times it by 2, then you add 3. So you'd multiply what's inside the bracket by 2, giving you 2x squared. And you add 3. That's how you do question B. Finally, question C. Probably the hardest one, but still easy. So it says solve f g of x is equal to 2g of x. So firstly we need to find what's f g of x. And we find g of x, which is 2x plus 3, and put that back into f, where you have to square it. This becomes 2x plus 3 all squared. Now I'm going to skip the part where I show you how to expand it, because I don't really have a lot of space. But basically what you would get is you would get 4x squared plus 12x plus 9. And it said that that's equal to 2g f of x. So you'd write this 4x squared plus 12x plus 9 is equal to 2 times g of f of x, which is actually just 2x squared plus 3. And so you do 4x squared plus 12x plus 9 is 4x plus 6. You just expand it. And then you take away 4x and take away 6 from both sides. You get 4x squared plus 8x plus 3 is equal to 0. And you can factorize this and solve it. But I'll do that on the other side. So 4x squared plus 8x, I think it was, plus 3 is 0. So what you do is you do 4 times by 3, giving you 12, and the two factors 6 and 2. So we'll do 4x squared plus 6x plus 3 is equal to 0. Now we'll take out, factorize these two independent of each other. 2x into 2x plus 1 plus 3 into 2x plus 1 equal to 0. So we get 2x plus 3, 2x plus 1 equals 0. X equals minus 3 over 2, or x equals minus half. Okay, which is basically minus 1.5 or minus 0.5. Question A, it says the function g of x is defined as 2x minus 4. So the rule says you multiply it by 2, then you take away 4. But the question asks solve for x. G of x is minus 6. So the way you would go around doing this question, in fact, what you would do actually is you'd write out g of x, which is 2x minus 4, and that's equal to minus 6. So we're going to add 4 to both sides. This gives us 2x, right? You add 4, negative 6 plus 4 is negative 2. So you divide both sides by 2. You get x is negative 2 divided by 2. Just simply put negative 1. Okay, and you can check this works by putting minus 1 back into the equation. So 2 times minus 1 is minus 2. Minus 4 is actually minus 6. So that's correct. The last question, again, is going to be one of those quadratic or some sort of solving equation. These are probably the harder level questions that you would probably encounter if you're doing harder, like the higher papers. But anyways, it says solve f g of x is 3 lots of that, which is the composition, but with g as the first function, or the last one to be done to. So first we'll do f g of x. So you take g of x, which is you times it by 3, add 1, which becomes 3x plus 1. This becomes the input of f. So you do f into 3x plus 1. And you have to square it, because from x to x squared you square. So this becomes 9x squared plus 6x plus 1. And g f of x, well, you do x squared and you put that into g of x. So 3 g of x squared. Rule says you multiply by 3, add 1. This becomes 3x squared plus 1. Okay? And it said that fg of x equals 3 lots of that. So we know that 9x squared plus 6x plus 1 equals 3 lots of that. Sorry. So 9x squared plus 6x plus 1 equals 9x squared plus 3. Okay? So what we do is now we would subtract by 9x squared both sides, giving us 6x plus 1 is 3. Subtract 1 from both sides, we'll get 6x equals, remember you subtract 1, 2. Therefore x equals 2 over 6, which is a third, which is 0.3 recurring. That is how you would solve it. So you form the quadratic equation 9x squared plus 6x plus 1, because you square 3x plus 1, and that is equal to 3 lots of 3x squared plus 1, which is 9x squared plus 3. You subtract 9x squared from both sides, giving you 6x plus 1 is 3, minus 1 from both sides, 6n is 2, x is a third. Alright. Second learning objective achieved. So now let's do this exam question. This is from the new specification in Maths GCSE specimen paper. So this is supposed to be very challenging. I believe it is the grade 9 or grade 8 A-star for sure. One of the higher questions in the entire GCSE you probably do, but it is fairly simple. So it says f of x is defined as 2x plus c. Alright, so we don't know what the constant is. It's just saying you times it by 2, then you add an arbitrary constant, which we do not know. And it said g of x is that same constant multiplied by x, and then you add 5. And they're telling you the composition is 6s plus d. And you can already pretty much guess what's going to happen, what you have to do. So firstly, you have to do the composition. So f g of x, this is going to be equal to f of, well, what's g of x? G of x says you multiply it by that arbitrary constant c, and you add 5. So this becomes the input of f. Now f, what you do is you'll do 2 times what's inside the bracket, which is cx plus 5, and then you add that arbitrary constant, c. Doing this, you get 2cx plus 10 plus c. They told you that the composition is 6x plus d, but you got different results, right? So let's actually write that out. So basically they're telling you that 6x plus d should be equal to 2cx plus 10 plus c. Now I'm not going to use the equal sign, I'm going to use the identity sign, because this is an identity, they are identical expressions. But anyways, they're telling you this, right? So let's compare the x terms. They're telling us that 6x is identical to 2 times something times x. Well, let's divide by x on both sides. We get 6 equals 2c. Does that mean, well, wait a second, if you divide by 2 both sides, you get that c is 3. Okay, so now we know that 6x plus d is identical to, that's 3, that's 2 times that, 6x plus 10 plus c, which is 3. So basically D, now let's actually compare the constants. That's basically saying that D is equal to 10 plus 3, which is 13. This is how you would solve this question. It's a 3 marker, so it's not meant to be difficult, and it is not difficult. What you do, you just find the composition, and you just use a bit of logic by comparing x terms and constants, etc. That's how you do this question. The second question, though, is a lot more difficult, obviously, because this came from an A-level past paper on composition of functions. So, it tells us that fx goes into 2x plus ln 2, sorry. So this will require you to draw upon knowledge of natural logarithms. If you don't know what they are, that's fine, unless you're taking an A-level course. But basically, if you don't know what natural logarithm is, you will need a law to do this. Basically, ln e to the ln of 4 or a is just giving you a, right? So that's the law you will require to draw upon from your natural logarithm knowledge of C3. But basically, e to the ln of a constant just gives it that constant. That is what you will require to do this question. Nothing more, nothing less. So let's actually do it. It says prove that the composition of GF. So GF, not FG, GF. Remember, they're non-commutative. Is 4e to the 4x. They're using this notation, by the way. As I told you, they might use different notations. So here, from a GCSE type of question, they use the simple fx. Here they use a lot more confusing, but still simple. F is x going to that. Now, you might be asking, what are these three symbols? This just means that x is an element of the real set of numbers, or basically x is a real number. So you don't have to worry about any imaginary units or complex numbers showing up. They're telling you it's a real number. That's what basically it means. It has, basically, there's a real set of numbers and x is an element of that, but it's just saying the x is real. Don't worry about that. So, g f of x. Alright, so first you will have to do f of x, which they tell you is 2x plus ln 2. Right? Ln is a log of base e. But anyways, now you have to put this into g. Right? So this becomes, put that instead of the input. Right? So they told you it will become e to double that. So this means that g f x goes to, well, it's e. Alright, so that is what the function f is defined as. And the function g, you start with an input e. The result is e to the double that input. Right? Raised to the double that power. So g So you will do g, but instead of x, the input will actually be this. What does that actually give you? Well, you do e to double that input. Which is what? E to the 4x plus ln 4. And using your knowledge of indices, when you're adding indices, that means you're multiplying with the same base. So we can just split this up. E to the ln of 4. Now, the only rule you need about natural logarithms is that e to the natural logarithm of a constant is just that constant. So e to the ln of 4 will just be 4. This means that the composite function is 4e to the 4x. And this is how you would do this type of question. It is much more difficult when compared with the last question, but obviously that is a difference between an A-level paper and a GCSE paper, albeit this is the old spec A-level, so the new one will be a lot more difficult. But basically what you do is the similar thing, but just change of notation. and you just put f of x into g of x. So you do g of that input gives you that, right? And then you just simply simplify it and split the indices, and you get this is the answer. You have shown this, so you'd get 4 marks on this question. Hopefully this tutorial has been useful, and hopefully you can do any question on composition of functions, at least for GCSE questions.